All right, let's look at the practice exam 2, number 4. All right, so let's look at part A first. Okay, apply row operations necessary to transform the matrix into reduced form. All right, so let's look at this. All right, so leftmost non-zero element has to be 1. So first row, so this is good. And the non-zero element here, leftmost non-zero element is 1. Right, and there's no row with all zeros, so we don't have to worry about that rule. Right, another rule was in the column of leftmost 1, everyone else has to be 0. So you can see that here's 0, so which is good, and here's the leftmost 1. Now this is the problem. So this guy has to be, we have to turn this guy into 0. Alright, so let's do that. So in order to turn this guy into 0, you always use the row that has leftmost 1, which is row 2. So you have row 2 right here. Right? Then multiply by the negative of the number you want to get rid of. Since we want to get rid of negative 3, so we're going to use multiply by positive 3 right here. Right? Then add it to the row you want to change. So add it to row 1, and that's going to be our new row 1. Right? So let's compute. Right? So in this row operation, only change occurs in row 1. So row 2 stays the same. So this is row 2, stays the same. So 0, 0, 1, 1, 2. All right? So let's do the row operation. Right? We multiply this row by 3 and add it to row 1. So here 0 times 3 is 0, added to 1 is still 1, right? 0 times 3 is still 0, added to 0, still 0, right? 1 times 3 is positive 3, then add that to negative 3, that will give you 0 right here, right? Which is exactly what we wanted. Right? 1 times negative 3 added to 0 is positive 3. Right? And 2 times 3 is 6 added to negative 6, which gives you 0. Right? So this is in reduced form. And last rule that we haven't checked was leftmost 1 has to be always to the right of leftmost 1 above. So that satisfies that. So this is in reduced form. All right, so that's part A. All right, part B, from this matrix, final matrix in reduced form, we are trying to find a solution. Right here, row 1, let's indicate that row 1, column 1 represents the coefficient of x1, and column 2 is x2, and x3, and x4. And last column is the right hand side. All right, so we know that the first equation gives you 1x1 plus 3x4 is equal to 0. So we got one equation, and we're going to always solve for the variable with the leftmost one, in this case x1. Right? So by subtracting 3x4 from both sides, we have x1 is equal to negative 3x4. Right? So we have that. All right, and row 2, right, gives you 1x3 plus 1x4 is equal to 2. Right? So we got that. Then we solve for x3. So basically subtract x4 from both sides. We have x3 is equal to 2 minus x4. Right? So we got those. All right. Then you can see that there are two conditions given on x1. One's for x1. The other one is for x3. Right? So x1 and x3 have to have a certain form. Right? But there is no condition given on x2 and x4. So x2 and x4 are free variables. Oops, sorry. This guy is a free variable. All right. which means that they can basically take on any real value. So we decided that maybe we should give value s for x2 and give value t for x4. Right? So since x1 has to be -3 times x4, and x4 now has a value of t, so -3x4 is -3xt. -3t. All right, and the same way, x3 is 2 minus x4, so we can write it as 2 minus t. Right, so x1 is -3t. Right, then s is the x2 value. Right, then x3 can be written as 2 minus t, and x4 is another free variable t. So that's how they get those answers. Right, I hope that this was clear.